Namaste children, welcome back again to this virtual class. In today's session we will be learning one of the most important topic under the chapter gravitation, that is thrust and pressure. These concepts are very important since most of our day-to-day activities are based on these two concepts, thrust and pressure. Before going to learn these concepts, let us have a recap on what we have learned in the previous episodes. In the previous episodes we have emphasized on the law of gravitation, right? The universal law of gravitation. So according to universal law of gravitation, we have learned that every object in the universe attracts every other object with some force. That force is directly proportional to the product of the masses and inversely proportional to the square of the distance between them, right? So F is equal to G into m1 into m2, or capital M or small m divided by r square. Here r is the radius of the earth when the object is nearer to the earth. If the objects are at a far distance, then we take distance square, so distance between the two objects, and the distance is calculated from the center of the two objects. Here the line of force acting on between the two substances are taken from the center of the two objects. This is also we have learned. And we have also learnt about the inverse square rule, which means the force exerted by the object is inversely proportional to the square of the distance, which means if the distance between the two objects are increased, then force will get decreased. If the force is increased, then the distance between the two objects will get decreased. This way we have discussed about the inverse square rule. In the later section we have learnt about free fall. Whenever any object moves under the influence of only the gravitational force, we call it as free fall. So the freely falling apple or any other objects, or if you throw any object upwards, then after reaching certain height the stone or other objects coming down to the earth, right? So these are some of the examples of free fall. While learning about the mass and the weight, we have seen that mass of the object remains constant irrespective of the places. That means if an object is having some sort of mass over the earth, then if you take to some other planets also, the mass remains same. So mass of the object remains same everywhere in the universe, whereas when we talk about weight, weight is not constant term. Weight of the object changes place to place. If you weigh any object in the earth, then if you weigh the same object in some other planet, say for example moon, the weight differs. We have seen that the weight of the object with respect to earth and the moon is 1/6 times lesser than on the moon. So similarly you can find the difference in the weight in planets to planets. This is what we have learned and completed, winded up the last episode. In today's session we will be seeing about the thrust and pressure. To understand this, let us have some of the basic questions, basic observations which we will see in our day-to-day activities. For example, you are much familiar with some of the facts in our day-to-day life. The camels can easily run on the desert, but in order to move on the loose sand, you feel it very difficult, right? The army tanks, which weigh around 1,000 tons of weight, can easily rest on the chain. The cutting tools have sharp edges, and the school bags what you are using, the strap of the school bag is wider. The tires of the vehicles, buses and trucks, you see wide tires they have. Why do they have such kind of large tires, or the strap of the school bags are wide? The camels can easily run on the loose sand. To understand this, to find the answer for all these observations, we should now understand the two important concepts. They are thrust and pressure. Let us understand one by one in detail. Dear students, thrust is the force in a particular direction. In the previous chapter in motion, we have discussed the difference between speed and the velocity. Speed is the distance travelled by an object with respect to time, whereas velocity is speed in a particular direction, right? Here thrust is also a force, but in a specific direction, in a particular direction. So simply we can say that the force which is exerted on an object in a particular direction is called thrust. So, thrust is simply force with some direction. Here the applied force should be perpendicular to the surface. If it is so, we call that force as thrust. For example, if you are pushing any object, the surface of the object is like this. If you are pushing it, then the direction of applied force is perpendicular to the surface. So, this force is called thrust. Let us now understand what is pressure. Pressure is the force applied on an object in a unit area. So, whenever force is applied on an object in a particular direction, we are going to apply, right. So, pressure can also be defined as thrust by area. So, pressure is equal to thrust divided by area, right. Let us see how the pressure changes on increasing or decreasing the area. Let us assume that equal amount of thrust, that is equal amount of force is applied on two objects having different area. For example, the first object we are going to apply 10 Newton of force to an area of 2 meter square. Similarly, in the second object also we are going to apply same amount of force. The thrust in both the cases are same, but here we are going to increase the area, that is 5 meter square. Upon substituting the values in the above equation, let us see what will be the pressure difference. Here thrust is 10 Newton divided by 2 meter square. Upon solving this, we will get 5 Newton per meter square, right. On the second object, the same amount of force is applied, that is 10 Newton divided by, here area is just increased to 5 meter square. Upon solving this, we will get 2 Newton per meter square. From this you can see that in both the objects we have applied equal amount of force, that is 10 Newton of force, but the only difference is here we have the area 2 meter square, whereas in the second object we have 5 meter square. Now you can relate it very well. When we applied equal amount of force on different areas, here in this case area is less. When the area is less, then we can see the effect of pressure is more. Here 5 Newton per meter square is the force, whereas when we increased the area of contact of the force, then we got only 2 Newton per meter square, which is less pressure. So, we can say that pressure is inversely proportional to area. That means, if area of contact is increased, then pressure will be decreased. If area is decreased, then pressure will be, or the effect of pressure will be increased. So, based on this pressure difference, based on the magnitude of the pressure exerted on an object, we can see different effects. On the basis of thrust and pressure, we can give the reason for the experiences what we were talking about in the beginning of this video. That is, the camels can easily run on a loose sand, the strap of your school bags are wider enough, the tires of the buses or trucks are wider, and the cutting tools have sharp edges. All these experiences can be explained on the basis of thrust and pressure. Let us understand one by one. Firstly, we will see about why camels can easily run on a loose sand. Camels can run or walk on the desert very easily due to the fact that the camel has wide foot. Due to this wide area of the foot, the pressure exerted by the foot on the sand gets decreased. We know that pressure is inversely proportional to area. If the area of the contact of the foot is increased, then the pressure exerted on the sand will be decreased, right? This is what we studied in the earlier section. So, in order to exert less pressure on the sand, their foot is wider enough to increase the area of contact on the sand. Due to this, camels can able to walk or run on the desert very easily, whereas it is bit difficult for us to walk on the loose sand because we have less area on our foot. So, the force exerted on the sand will be more. Due to less area what we have on your foot, which exerts more pressure on the sand. Due to this more pressure, it is very difficult for us to walk on the sand or a desert. Let us see another experience. The strap of your school bag. is wider, right? So the same principle will apply here. If your school bag have very thin strap and one of your school bag have wider strap, then what is the difference between these two straps? One is having less area, right? Another one is having more area. Once again the same principle applies here. If the area of contact on your shoulder is more, then you will get less pressure on your shoulder. If the strap of your school bag is thin, then the area of contact is less on your shoulder, which can cause more pressure on your shoulder. That is why your school bag is always preferred to have a wider strap so that you will get less pressure of your school bag. Let us now discuss another experience of knife. You know that the edge of the knife is sharper enough to cut the vegetables and all. If the knife is blunt, then it is very difficult to cut vegetables or other objects, right? If the knife has sharp edges, then you can find that the area of the contact is very less. Once again the same principle comes into play, that is pressure is inversely proportional to area. In order to increase the pressure with a small effort or less effort, we need to decrease the area. We know that on decreasing area the pressure will be more. In case of a blunt knife, you have to apply more force in order to cut it, right? If your knife is blunt, then you at that time you can see that the knife has increased its area. So due to this increase in area, even with the larger force, it is not very easy to cut vegetables and other objects, right? At that point what we do? We usually sharp the edges with the help of sandstones which is available. You are familiar with the sandstone, right? In all these cases what we are trying to do is, the cutting tools are always sharpened so that its area will be decreased. On decreasing the area, then with less effort or by applying less force also you can cut the object, because it will exert more pressure on the object. Due to this you can cut it easily. Hope you understood thrust and pressure and the effects of the pressure on various observations which we encounter in our day-to-day life. Likewise, you can find a reason for various other experiences which we have not discussed on the basis of pressure and thrust. Let us now understand the pressure exerted by fluids. Before that, you should know what is fluid, right? Fluid is anything which can flow easily. For example, when you pour water on any surface, it easily flows, right? Water flows. Similarly, when a lighted incense stick is kept at the corner, then the entire room becomes spread by this smoke or the fragrance of the incense stick. So from this we can say that the liquid and the gases are able to flow easily. Such substances are called fluids. Whether these fluids exert pressure? Yes, children, fluids exert pressure in all direction, even in the upward direction also it can exert pressure. In the lower classes you must have studied the liquid kept in a container exerts pressure on the walls of the container, even at the bottom of the container, and you must have also studied that as the depth increases, then the pressure exerted by the liquid will be more, supported by some of the activities also you must have performed in the lower classes. Same thing we are going to recall here also. You are much familiar with the stone, iron nail and all that, right? When these substances are put in water, then immediately it goes down, it sinks, right? If you place a capped empty plastic bottle on water, then it will not get immersed, it will just float on the surface of water. By applying force or by forcefully, if you try to immerse the plastic bottle into the water, then it will go down, go to a certain depth. But as soon as you release the bottle, immediately it comes and floats over the surface of water. The water bottle comes with certain force. Where does the force come from? This is the force exerted by the fluid towards upward direction. The force with which the plastic bottle, the empty plastic bottle comes over the surface of water, that force is called buoyant force, and the phenomena is known as buoyancy. So we can define buoyancy in terms of the upthrust exerted by the fluid. So water and are the fluid substances which can have the ability to exert upthrust. Upthrust means force in upward direction. This upthrust force is known as buoyant force. Due to this buoyant force, the objects are coming upward. Now, some of the experience in our day-to-day life, we feel the presence of this upward thrust or the buoyant force. Suppose if you lower a stone into water, as soon as you are above the water surface, then you will feel little bit heavy. As soon as you release the stone tied to a string into a water, as soon as it goes into the water, then you will feel the weight is little bit less. How does this happen? This is because when the stone is lowered into the water, water exerts upward force. Due to this upward force, you will feel little lighter than before lowering the stone into the water. In the previous episode, we have learned that earth attracts every object towards it. Now, over the earth surface, we have a bucket full of water. In that, if we add a plastic bottle, then as soon as it reaches the top surface of water, up to there the object gets attracted towards the earth. As soon as it touches the water, or if the plastic bottle is forcefully immersed into the water, then after releasing it, immediately it comes upward, right? So, where does the gravitational force go then? Here, the gravitational force is the weakest force, and the force exerted by the fluid towards upward direction is more. Due to this fact, we find the objects are pushed towards top of the water. Let us now discuss the factors that affects buoyant force or the buoyancy. There are two important factors on which the buoyant force depends upon. The first one is the volume of the substance that are immersed in the fluid or the liquid. The second important factor is the density of the liquid in which the substance is being immersed. Let us discuss how the volume of the substance that are immersed in water is affecting the buoyant force. Let us now learn the first factor. The buoyant force exerted by the liquid depends upon the volume of the solid substance that is immersed in water. If you immerse a solid substance, the volume, if the volume increases, then buoyant force will also increase. On complete immersion of the solid substance, the buoyant force will become maximum, and after that it will be constant. It does not depend upon mass of the object. Let us take an example. We have two balls. Here I have taken a plastic bottle, one is empty plastic bottle and another one is the same plastic bottle in which water is being filled. If you weigh, both will have different weights, but their volumes are same, right? If you immerse both the objects, both the plastic bottles in water, then you can find that the total amount of water displaced by both the objects are same, which indicates that the force exerted by the liquid is same for both the objects irrespective of the mass of the object. The buoyant force exerted on both the bottles are same, they are independent of mass. I hope you understood the first one. The second factor on which buoyant force depends is the density of the liquid. If the density of the liquid is more, then it will exert more buoyant force. If the density of the liquid is less, then it will experience less buoyant force. On the basis of this, let us take a familiar example so that you will understand this concept very easily. You will find it easy to swim in a sea water, whereas bit difficult in fresh water. What could be the reason? Here in case of sea water, there are plenty of suspended salt particles. Because of this, the density of the sea water will be more. We have learned that more the density of the fluid, more will be the buoyant force. When you swim in a sea water, then due to high density, the upthrust will be more. As a result of this, you will find it easy to swim in a sea water. Whereas in case of fresh water, the suspended salt particles are very less, the concentration is very less, so the density is also very less. We know that if the density is low, then the upthrust force will also be less. So when you swim in a fresh water, then you will find very less upthrust force, so you will be less pushed towards the top, so you will find it difficult to swim in a fresh water. We know that some of the objects when put in water floats and some of the objects sinks. Now the question is, why do some objects sink and why do some objects float on water? To understand this, we need to understand one more important term, that is density. The object will sink or float on water based on the density of the substance. If the density of the substance to be immersed in water is more, then it will sink in water. If the density of the substance which is immersed in water is less, then it will float on water. If the weight of the object, here weight is the gravitational force, if the weight of the object is more than that of the buoyant force, then what will happen? The object will come down. That means it will sink in water. If the buoyant force exerted by the fluid, liquid is more, then the object will float. Let us now understand what is density. Before understanding this, look at the screen. Here I have two balls. One is the football and another one is the stone ball of the same size. Here you will find the volume of these two balls are same. Here the only difference is they are differ in their masses, right? If the mass is more, then you will feel little heavier. If mass of the substance per unit volume is less, then you will feel it lighter. On the basis of mass per unit volume, we can identify the heaviness or how heavy or how lighter the object would be. So mass per unit volume of a substance will give you the density of the substance. So density is equal to mass by volume. The SI unit of density could be found out by substituting the units. We know that mass of the SI unit of mass is kg and volume is meter cube. So the density will have SI unit of kg per cubic meter. Now we will see relative density. It is not at all possible to find the density of all the substances that exist in the universe. In order to find the density of other substances, we compare the density of a standard substance, from that, with reference to that we find the density. So we find the relative density of other substances. Here the density of water is found to be 1000 kg per cubic meter. It was found that in 1 cubic meter the total mass of water will become 1000 kg. So this water, the density of water as taken as reference, and density of other elements or other substances are compared with respect to water. So we call it as relative density. Here the density of a substance under specified condition remains same. So the density can be considered to be one of the characteristic property upon which we can decide the purity of any substance. Let us now learn how relative density of various elements around us could be found out by knowing the density of water. With reference to the density of water, we can easily find the relative density of other substances. Here one thing to note is that the relative density don't have any unit, because the relative density of a substance is the ratio of density of that substance with respect to some other standard element or standard substance. Here water is taken as the reference. So the density of the new substance which we are going to find is compared with water. So it is just the ratio, so it does not have any SI unit. This thing you always keep in mind. Let us see the first numerical problem. An object of mass 50 gram has a volume of 20 centimeter cube. Calculate the density of the object. If the density of water is 1 gram per centimeter cube, state whether the object will float or sink in water. Whether the object will sink or float in water, that will be known only after finding the density of the object to be immersed in water. Firstly, the quantities which are given in the question that we write. So here mass of the object is given as 50 gram and the volume is also given in the question. So volume is equal to 20 centimeter cube. Now we have to find the density. We know that density of any substance can be found out by the formula of mass by volume. This is a simple equation. By using this you can find the density. Most of the time students skip numerical part whenever comes in the examination. Dear students, don't skip any of the numerical problem. It is very easy to solve. The only thing you need to do is just to remember the easy formula. With the help of this formula you can solve within a minute and you will get full marks also. So mass and volume are already given in the question. The thing is just you have to substitute the values. So mass is given as 50 gram divided by volume is given as 20, 0 gets cancelled. So here we will get 2 point, here volume is in centimeter cube, right? So here 2.5 gram per centimeter cube is the density of the object which is immersed in water, right? Let us find whether the object will sink or float. It is given in the question that density of water is 1 gram per centimeter cube. Now compare the density of water and the object to be immersed. Here the density of the object to be immersed in water is more, so the object will sink. If the density of the object to be immersed in water is less than the density of water, then it will float, but here the density is more, so the object likely to sink in water. So we can write it as, since the density of sink in water. Alright children, this way such type of numerical problems could be solved. Let us see another numerical problem based on the relative density. Let us see the second numerical problem. The relative density of silver is 10.8. Here no unit is there. Relative density don't have any unit, right? If the density of water be 1.0 into 10 to the power 3 kilogram per meter cube, calculate the density of silver in SI unit. This is very simple numerical problem. Straight away by substituting the values in the equation we can find. So we know that relative density is equal to density of the substance divided by density of water, right? Density of water. Here relative density is already given as 10.8. You have to find the density of the substance. So by rearranging this equation straight away we will get, right? So here density of silver, relative density of silver multiplied by density of water, right? So both the values are given here. So relative density of silver is given as 10.8 multiplied by density of water is given as 1.0 into 10 to the. So substitute this value 1.0 into 10 to the power 3 kg per meter cube. Upon solving this, what we will get? We will get 10.8 into 10 to the power 3 kg per meter cube. So this is one step solution. The thing is you have to remember the formula of relative density. By substituting the values in one step you are getting. This way numerical problems on relative density could be found out by knowing the formula. Hope you understood how relative density of various substances could be found out by using simple formula. With this I would like to conclude today's session. Before concluding, I would like to give some easy home assignments which you can practice at home. Here is your home assignment. So dear students, that's all we have for today, and we have completed the chapter Gravitation. See you all on another day with a new chapter. Till then, keep learning, take good care of yourself. Bye.